So we're going to work on 7.5 today. We're applying tangent ratios. Now you're going to notice that up at the front of our board, there are three things on my whiteboard. I'll write them on the slide. There's so, ka, and then to, ah. It's kind of a saying similar to empty garbage before dad flips, you know, in music, or FACE. Okay, when we say SOHCAHTOA, today what we're going to look at is we're going to look primarily at the TOA. Okay, so and ka, those are coming tomorrow. It's sine, cosine, and tangent is really what it is. But again, today we're going to look at tangent. When I do tangent, you're going to notice that I've got the T, I got the O, and I got the A. Okay, the T stands for tangent. And then what the O stands for is opposite. And the A stands for adjacent. Now this is used when we work with 90-degree triangles. You have to have a 90-degree triangle to use trig. Right? And so you can say, well, why use trig if I've got 30, 60, 90s, 45, 90s, I've got the, the x root 2. Like, why would we use trig then? Well, trig takes place when we don't have those special triangles. Rather than a 45-degree angle, we have something like a 42-degree angle. It works all the time for trig, okay? So let's take a look at the triangle. So let's say I have a right triangle like this. And let's say that this is angle x, because you'll notice over here I had tangent x. Okay, so I've got my right angle. If I look at the sides of this, this side right here is called the hypotenuse. That's always the hypotenuse, always. And you guys should know that. We've talked about it several times in a right triangle. It's the longest side of a right triangle, and it's opposite that right angle. Okay. Now, if I look primarily at the angle x, the side that's right next to it, this is called adjacent. Adjacent or next to. Notice that it's touching angle x. On the other side that is not named, that's considered the opposite. So if that's the angle that I'm looking at in particular, those are the sides that are labeled accordingly. Questions? Okay, so let's go ahead and let's go down here. And it says, set up the tangent ratio for the triangle. So let's look at this one. You're going to notice that they gave me angle A. So I'm looking at this angle. So I'm going to set up tangent. So T-A-N. I'm just doing tangent today. I'm going to put an uppercase A. I'm going to go equals. And then I'm going to put a ratio or a fraction bar. Now, if you saw on the tangent, you had the TOA. The T stands for tangent. O stands for opposite, right? And so if I take a look at the triangle that I have right here, this is my hypotenuse. Which number, the 5 or the 12, would be opposite? It'd be the 12. The 12 is opposite, and what would be the adjacent? It would be the 5. We okay with that? Makes sense? Again, the 5 is what's touching it, so that's why we would do this being the adjacent, and then opposite of it on the other side, that would be considered the 12. Okay, and right now all we're doing is we're setting up triangles. We're not solving anything, it's just getting used to the setup. All right, let's take a look at this next one. Again, I'm going to look at the A, which is the angle. So I'm going to go tangent A equals. Again, I'm looking at the side that is opposite the A, and that would be what? It would be 33. And the adjacent would be? It would be 10. That's right. And you go, well, why didn't I use that 34.5? Again, this is that hypotenuse. And we don't use hypotenuse for tangent. Questions? Okay, let's go to this next one. I got angle A. Again, tangent A. What do we pick up for the opposite? 8. What do we pick up for the adjacent? 25. Questions on this? Okay, let's go to the next one. Again, I've got angle A, so I pick up tangent A equals. Opposite would be 9. Adjacent would be 35. Any questions on these? Again, we're just looking at tangent today. So we're looking at the opposite and we're looking at the adjacent. All right, let's go ahead and we're going to look at your calculators. So if you'll grab your calculators, please. You need to make sure that you have a calculator. We can't do trig without it. We cannot do it without it. So you got to make sure that you have a working calculator. Also make sure on your calculator you have a DEG on it. If it says RAD, it's in radians. You want it in degrees, so you might have to reset your calculator to make sure that it says DEG on it, not RAD. Okay? We're working in degrees today. Okay? So let's go ahead then. We're going to solve for x. So I'm going to grab tangent again, like I've been doing, and rather than putting in a or an x, we're actually going to put in 30 degrees because that is the degree measure they gave me. Now you can say, well, Mrs. Medvik, when do we use the 90 degrees? The only thing the 90 degrees does for us is it tells us that we can use trig. You'll never put 90 degrees in for the degree measure next to tangent. Okay? So we're going to go ahead and put 30 in. What would be opposite of 30? I heard it. 7, yes. What would be adjacent? The x. Okay, now, this is what we did in the last example. Now we need to solve. So this is how we're going to solve. If you notice on this problem, down on the bottom in the denominator, that's a variable. We don't want it down in the denominator. So to be able to get rid of it, what we're going to do is we're going to multiply both sides by x. And what that does is it cancels out these x's. It gets rid of them. And so what I have left over then is x tangent 30 equals 7. So I got rid of the x in the denominator. That's what that did. Now I'm showing a lot of work in black for you. All you would have to do for work is the green part, but I'm showing you how I'm getting this for the first problem. And then the next problem, I won't show all the work because you don't have to show all the work. You just have to do the green part. All right, now I want x by itself, and you'll notice it's attached to the tangent, and it's attached by multiplication. So to get rid of that tan 30, I'm going to divide. So I'm going to divide both sides by tangent 30. And what that does is it cancels out these two pieces. So what I end up getting is x equals 7 over tangent 30. Now what you're going to do, this is where the calculator comes in, you're going to go x equals, make sure that you clear your calculator, and you do need to practice this. So I'm showing you how to use your calculators. This would be an ACT question. So you would take this 7, you'd go divided by, push tangent, and you're going to push 30, and then push equals. Right? And I end up with 12.5. 1, 2. It's not a degree, or it's not a degree measure, it's a side measure. So it would be like units or inches or feet. Okay. Questions on this? Okay, let's go ahead and let's go to the next one. We'll go to this one. Try to find some room. There we go. All right, so we're going to pick up tangent. And the tangent degree measure would be what? 44. Very good. Equals, okay, what's opposite the 44? X. What's the opposite? 17. Now, compared to the last problem, notice that the denominator is not X, is it? It's what? 17. So to get rid of the 17, I'm going to, yes, multiply by 17 on both. So you end up with 17 tangent 44, and that's what X equals. So everything you see there is what you would actually write down on your paper, because I want to see what you're putting in your calculator. So I'm going to go X equals, I'm going to grab my calculator, make sure you clear it, 17 tangent 44 equals, and what do you guys get? Yes, 16.42, and it would be like units, like centimeters, feet, that type of thing. Questions on this? You're doing trig. This is the basics of trig, not super hard, okay? All right, let's go to this one. So I'm going to grab tangent. What should I put next to tangent? Yes, excellent. 55, that's the angle measure, equals, what do I put in the numerator? X, denominator, 8, okay? I want to get the X by itself, so what am I going to do? Multiply by 8. So I get 8 tangent 55 equals X. X equals, so we're going to grab our calculators again, 8, then tangent, then 55 equals, what do you guys get? Yeah, 11.43. And again, side length. We're not going to do angle length for a couple of, or angle measure for a couple of days. All right, let's go ahead and do this one. Again, I'm going to grab tangent. Tangent what? 37 equals numerator over X. Okay, now what do I do? Yes, very good. I'm going to multiply by X on both sides. So X tangent 37 equals 54. So this is the work you would show. If you want to do more, you can. This is the minimal. Okay, I want X by itself, so I'm going to. Very good. So I get X equals, I'm going to divide by tangent, 54 over tangent 37. X equals, again, grab that calculator. What do we get? Yes, 71.66. Very good. Questions on that? Okay. Last one of this type. Tangent, what? 65 equals X over 11. Sometimes when they're kind of skinny, they get a little bit more confusing. So if you have trouble with the opposite, just think, what's my hypotenuse? That you should be able to pick out, and what's adjacent. You know the leftover is the opposite. So what am I going to do to get X by itself? Multiply by 11. So 11 tangent 65 equals x. X equals, again, clear your calculator. We get, that's what I got, good, 23.59. Any questions on setting these up? Again, not super difficult. It really is not. And you go, well, gee, people talk about trig and it's so scary. There are harder pieces to it. And again, this is the basic of it. But trig isn't real difficult. Once you understand it, it's very useful. It really is. All right, let's move on. This is a type of ACT question that you would have. You need to find the perimeter of the triangle and round to the nearest whole number. So if we are doing perimeter, what are we finding? The outside, the distance around, okay? So I got an 11, which is great, but I am missing, let's call this x, and let's call this y. I need those pieces too to be able to find the perimeter. Okay, so I can't use Pythagorean theorem. I can't do the 45, 45, 90, 30, 60, 90s, because this is a 42-degree angle. That's why we have trig. That's why we have its use. Okay, so I'm going to go tangent of what? 42, that's the angle they gave me, equals, what's the opposite? 11. What's my adjacent? It's x. Questions? It's all in the setup. Once you get the setup, it's a little bit easier. Okay, so how do I get the x by itself? Multiplied by x. Good. So x tangent 42 equals 11. And then we by, good, we're going to divide by tangent. So x equals 11 over tangent 42. Now be careful with cutting off too early on this. Okay, so I'm going to take 11, divide it by tangent 42. And I get 12.22, which is fine, but it's fine on paper. But remember, I'm trying to find the perimeter. So you want to be a little careful on this, okay? So this is 12.22. Now help me out here. I used tangent. How would I go about finding my hypotenuse? Because I don't have sine, I don't have cosine. All you got right now is tangent. So what other tool could we use to find what the hypotenuse is? What's that handy dandy tool I say we always go to if we have a right angle? Yes. Yeah. A squared plus b squared equals c squared, our Pythagorean theorem, right? Okay, so I'm going to grab that. A squared plus b squared equals c squared. That's that handy thing. What would be my a squared? Sure, I can do 12.22. What would be my b squared? It's my 11, yep, and my c squared I'm going to put in as y squared. Again, the c is my hypotenuse, and that is c, or is that's y. So make sure you take the c out, you put in the y, because that's what's in my picture. Okay, so I'm going to go ahead and I'm going to leave that 12.22 large in my calculator, and I'm going to square it, and I end up with 149.25, something like that. I can write it shorter on my paper, but keep it large in your calculator, okay? Plus 11 squared, 121, equals y squared. Okay, y squared equals, I'm going to add 121. I'll get 270.25. Now, what do we do to get rid of the squared? Very good. Yeah, we're going to square root it. Notice how I'm going to show that. And then we're going to do our calculator magic. So I get y equals, and I'm going to take the square root of that large number, and I end up with 16.439. Okay, and I'm not done yet because, again, the problem asks me to find the perimeter. That's right. So the perimeter, I'm going to take my 11 plus my 12.22 plus my 16.439. Perimeter equals, so go ahead and add those up. And I get 39.66, which is approximately 40. We'll put units. Okay? Now that's how you find the perimeter, okay? In your assignment today, they're asking you to find the area. So again, area equals 1/2 base times height, or area equals base times height divided by 2. And on our triangle, if we draw a right triangle like this, okay, it doesn't really matter what I put in for my base or my height, but keep this in mind that this is my hypotenuse, and it would not be one of those. So looking at it like this, the height is the one that goes up and down, and the base is what it sits on. Okay, but it would not be the hypotenuse. The hypotenuse is never the base or the height if I have a right triangle. Okay. Questions on this? Okay, let me know if you have questions.